Now we're going to look at dimensionless analysis. So this is a high-level mathematical technique of looking at fluid flow problems and any problems really, any mathematical problems. Um, and the point is that by identifying the correct dimensions to use, one can create dimensionless equations which allow you to solve the equation once, and instead of solving just one problem for a specific situation, you actually are solving a whole set, an actually infinite set of problems that are all identical in terms of the mathematical relations involved. So you get one solution that actually applies to an infinite number of problems that share certain things in common, even though they may be quite different from each other, at least superficially. So the other thing that dimensionless analysis does, therefore, is it allows you to see which problems are physically identical from a mathematical point of view, systems that will behave the same even though they appear to be different. And we'll explore what that means after we've derived these equations, and we can use them to sort of to see like why some flows that are superficially very different actually are going to behave in exactly the same way. And therefore, if you solve one of them or study one of them experimentally, you've also arrived at information about other flows that you have not yet studied, but which are identical because of the math. So this is particularly useful not for people who are, say, going to develop a particular pipe network for a heating system, a specific heating system, or who are going to develop hydraulics on a particular brake line. Dimensionless analysis is generally used by people who are studying more the nature of fluid flow itself. So really, how do fluids behave in a more general way to provide guidance to people who might be designing specific things. And and often if they're doing something new, some new aspect of fluid mechanics that really hasn't been studied thoroughly, they might start using dimensionless analysis as a way to understand what's really going on at a very fundamental level. So those are often the people that are doing this kind of work, and some of you will probably go on to do that kind of work. Some of you won't. Some of you will, not do much fluids in your careers. Others will go on to use fluids, but in very specific situations where you need to size a particular pipe or size a kind of a pump. But some of you may go on to really study fluid mechanics at a deeper level, either because you choose to go to graduate school and become a real expert in fluid mechanics, or just because you end up in an organization where that turns out to be something that they really care about. So examples of some organizations where the fundamental study of fluids is really relevant, where they do a lot of it. NASA certainly has been doing this for a very long time. The Navy, of course, very interested both in airflow and water flow. Not only do they worry about boats, they worry a little about planes, but more importantly, they worry about weather. So a lot of stuff, and the Navy is very interested in how the weather is created and how weather patterns form. So they do a lot of work with atmospheric fluid flow and ocean fluid flow, in addition to the obvious applications for just fluid flow around boats and propellers and stuff like that. The Air Force, of course, certainly again very interested in weather, but also very interested in how planes fly. Boeing, I mean, they make airplanes, so they're really interested in how fluid flow works. Lockheed Martin, they also make airplanes. They make a lot of things. I mean, Lockheed Martin's huge, but airplanes are among the things they make. They also make torpedoes and some other things in the water. Climate research groups, of course, a big deal. We just said this is weather related, and how climate, really changes depends very, very strongly on ocean currents, winds. So a lot of research going on trying to connect ocean and wind and waves, to give better predictions of both weather and climate, which are two different things. Car companies, we've already discussed how that's been an active area of research for a long time, both for trying to make cars go faster and hold the track, using airfoils to keep cars in good contact with the ground, and to just make cars more fuel efficient. A lot of study about aeronautics there. An electric boat, they make submarines. So that's GD, General Dynamics Electric Boat, down in Groton. They make all the big nuclear submarines and hire a lot of our students. So that's just some examples, but just to say, this kind of dimensionless analysis, and it's not what you're going to see at your plumbing supply shop, but it is what you would see if you end up working for an organization that really is interested in advancing the whole field of fluid mechanics.